Now you have to decide the order and degree of this differential
Order
equation.
is 1, degree is 1.
Ah, don't be so fast, okay? Just give it a minute and think and let me know. Just think for a few seconds.
We will have to differentiate it.
Yes. Now in this equation, there is a small problem. See, this small problem is this integration sign. See, what is our definition of differential equation? That it consists of the differentials, isn't it? Have we said that it consists of integration and anything, any other signs? Is it there in the definition?
No, ma'am.
So it must not have that, okay? So we have to eliminate this. So what we are going to do, we are going to use a very basic concept. You must have heard that integration is basically anti-derivative. Have you heard of this anti-derivative?
Yes, ma'am.
Yes, ma'am.
Yeah. So integration is basically anti-derivative. So if we differentiate the integral sign, it is going to cut it. It's going to vanish. So for that, what we will do, we are going to differentiate this whole thing. Now to differentiate all this, this is obviously it's a product. So we are going to use product rule here. We are going to use product rule here. So let me just start doing it. So x square d cube y by dx cube, right? Plus 2x. Okay. Then the next one again, x into again d square y. So this will become 3x plus just dy by dx because derivative of x is 1. Now plus d by dx of the integral, right? So this is going to cut and we are going to be left just with 3. And right hand side, obviously derivative of sine is cos. And now we have got a proper differential equation. So now you can tell me the order and degree. So what will be the order?
3.
Order
is
3.
And what will be the degree? Degree
1.
will be 1. So you remember this important point that if you have something like the integration, it needs to be eliminated by doing like this, by taking the derivative, and then you will get the order and degree. Okay, let's try another one. Okay, what about this?
Please
The previous.
What happened? You want to see the previous? Yeah.
Yes, ma'am.
Yeah.
Can you repeat it once more? The second step.
Second step, as in this step.
Yeah. Yes, ma'am.
Yeah, so here we are differentiating all this, right? In differentiation, see, we have got a product here. So what I've done, I've used product rule. You know the product rule, right? D by dx of uv, isn't it?
Yes, ma'am.
So that is what I've used for both these terms. And this integration is going to get cut. Why? Because integration is anti-derivative. So if I take d by dx of anti-derivative, basically what is going to happen? It's going to vanish, right? It's something like this. This is what we are talking about, anti-derivative.
Yes, ma'am.
This is what will happen, right? Getting it? Yeah, so
Yes,
this
ma'am.
will vanish, this will be 3. And derivative of sine, you know, that is cos. Got it?
Yes, ma'am.
Yes, ma'am.
Okay, so if you have finished writing, then we can just go to the next one. All right. Yes, you have to decide the order and degree. So can you decide it?
Order is 2
Order is
Mhm.
2.
and
No.
degree is 5.
We will have to manipulate something.
No, degree is, ma'am, degree is 1 out.
Okay, let's just see. Yeah, you have to manipulate something. What you have to do is see basically what is our definition telling us? It consists of ordinary derivatives, right? So
Yes, ma'am.
there should be no radicals. That means even the square root sign needs to be removed. So what we'll do is we will write this in terms of radical form by taking the power. So this is the fourth root, means raised to 1 by 4, right? And this is going to be 7 plus 3 y dash square, and this will be raised to half. Now I have to get rid of these powers. So what do I do?
Multiply by 4.
Yes.
Both sides.
Raise it both sides, raise it to 4. Now what will happen? This will vanish. So I will get this raised to 5 and 7 plus 3. Now remember, this is first order derivative and this will be squared. Okay, now you know, even without expanding this, we will be able to tell the order,
Yes,
because
ma'am.
highest
Order is
derivative.
2 and degree is 5.
Yes, right. Order is 2 And degree is obviously the power of the highest order derivative. So degree is going to be 5. See, supposing you had a different situation, let's say that, let me just tell you. See, let's say that we had an equation where it was this way. Okay. Let me just change the problem a little bit. And supposing we had 3 and then this was squared. In this case, what you would have had to do, you would have to square this. You would have to square this because the order here obviously would have been 2. But to get the degree, you can make out the degree easily. It's not that difficult. This is just a power raised to 2. So in that case, this order would be 2 and degree would be 4 of the square. Idea is clear to everybody?
Yes, ma'am.
All right. So I think order and degree you all have understood properly now, right? So if you these type of questions, it's quite possible that they could be part of the objective type of questions, provided the paper pattern remains the same as before. Like last semester, I think you had what was the pattern? Like objective 10 into 1, no?
Yes, ma'am.
10 into 1 was that MCQ, right?
Yes, ma'am.
Yeah. So if this semester, if the pattern remains the same, that same pattern is being followed, then in that case, you can expect this order, degree, etc. to be part of those type of questions. Idea is clear? Okay. All right. Now let's go to solution. So we have developed the definitions of the differential equation, just a general differential equation. Then we saw what is ordinary. Then we saw what is partial. Now we are talking about the solution of the differential equation. So basically, there are ways to talk about the solution. So most general way to talk about the solution is solution. It's also called integral. It's also called primitive. Okay. It's a relation between the variables which should not involve any derivatives, and also it should satisfy the given differential equation. So in your solution, the derivative must not be there. And if you solve, if you differentiate this, like say, for example, this is the solution to this differential equation. So if you differentiate this and substitute here, then we should get this RHS equal to 0. This is the meaning of should satisfy the given differential equation. Now, what are the different ways of classifying these solutions? So first way, it's a general solution, or it is also called a complete integral, or it is called a complete primitive. When do we say that a solution is a general solution? If the number of arbitrary constants is equal to the order of the differential equation. All right. So you'll are you following the train of thought? You know what is order, right?
Yes,
You
ma'am.
know what is order. Yeah. So if the number of arbitrary constants which are generated is equal to the order, then it is a general solution, or complete integral also it is called, or it is called a complete primitive. Now this general solution becomes a particular solution when we give some particular values to the arbitrary constants. Okay. So if we give some particular value to the arbitrary constant, then it is called as a particular solution. So this is one example of the particular solution where the arbitrary constant has been given a value of 2. And lastly, we have got a solution which is called a singular solution. So why it's called singular? Because it cannot be obtained from the general solution. So we are going to be dealing mainly with 1, 2, and 3. We will not have occasion to make use of this fourth one. Okay, but I've just given you information of everything. So this is just general definitions about the solution. Okay, now let's move to an important part. Formation of the differential equation. How to form the differential equation. Those of you who are making notes can now write this heading, formation of differential equation. Once you have done it, just let me know, okay, that you're finished.
Yes, ma'am.
Done. All right. So remember one basic thing. Whenever we are forming a differential equation, our objective is going to be to eliminate the arbitrary constants. Okay, this is going to be our aim.
What is the meaning of arbitrary?
See, there are something called as a true constant and there are arbitrary constants. These arbitrary constants can take any value. Whereas for the true constant, it may not necessarily be able to take any value. Is that clear to you why it is called arbitrary?
Yes, ma'am.
Yes, yes.
In differential equation, are we going to have true constants?
Sometimes yes. There are some differential equations which are very specific. In that case, it will be specified to you. See, for example, can you just give it a thought for 1 minute and tell me some true constant which won't change? Just you all think. You know many such true constants, but can you just think and tell me? Many such you know. In your earlier classes, many times you have come across such true constants. Will anybody tell me? At least value of?
Epsilon.
No. Think little properly and tell me. Huh?
Planck constant.
Have you heard of this?
Constant.
Yes, gravitational constant. How much is it?
6.67 into 10 raised to power minus 11 value of G.
Okay. All right. What else?
9.8
9.8
meter per
yes,
second square.
meter per second square. Okay. All right. Now, yes, which other constants? Just think which are true constants. That means these are not going to change.
Epsilon. Permittivity.
Epsilon and all, it's not even to be, it's a transcendental number. So any other number which you have studied, like in your physics and all.
Planck's constant.
Planck's constant. Okay.
Avogadro's number.
Avogadro's number. Yes. Okay.
Charge on electron.
Yeah. So, all right. So you have an idea about it. So such kind of numbers, they won't change. Idea is clear to you.
Yes, ma'am.
Got it or what? Yeah. So that is why here we are using this word arbitrary. That means they can take any value. All right. So basic aim when you're forming the differential equation is going to be to eliminate these arbitrary constants. Now, how are we going to do it? So let's see this example. So supposing you are asked to form the differential equation from this equation. Here A is the arbitrary. Sorry, here I just wrote x square. This will just put it a square. This is, yeah. So ax minus a square. Now here a is the arbitrary constant. So the method is like this. You are going to differentiate as many number of times as the number of arbitrary constants. Now, how many arbitrary constants are there in this equation? How many?
1.
Therefore, you are going to differentiate how many times? Only once. So what I'm going to do, I'm going to just find only dy by dx. What is the value of dy by dx? Who is going to tell me?
A.
That's it. Derivative of a constant is 0. So the remaining term is 0. Okay. So dy by dx is equal to a. Now what I have to do? What is my aim? To eliminate the arbitrary constant. I don't want it. So for that, supposing I call this as equation 1. I call this as equation 2. This I am going to substitute here. That means how I'll write this? Y is equal to x into dy by dx minus dy by dx whole square. And that is our required differential equation. Idea is clear to everybody?
Yes.
Got it? Okay, very good. All right. Now we'll see the next one. So you have to form the differential equation from this given equation. Okay. So what is it? Y is equal to a e raised to 2x plus b e raised to 5x. So we have to eliminate the arbitrary constants. How many arbitrary constants are there? It is given to you. A and b are arbitrary constants. How many are there?
2.
2. So how many times will you differentiate?
2 times.
2 times. So here when we say dy by dx, so this is going to be dy by dx is equal to, now everybody knows derivative of e raised to 2x, what it is? 2 into e raised to 2x. So therefore here we will write 2a e raised to 2x plus 5b e raised to 5x. Is this much clear to everybody? First derivative.
Yes, ma'am.
Now second derivative. So if you differentiate one more time, this will become 4 e raised to 2x. So here we are writing 4a e raised to 2x. Plus same way this will become 25b e raised to 5x. Now this is over. That means we have finished differentiating. But now what we have to do? We have to ensure that this a and b are eliminated. So we have got two equations. Now you all have heard, everybody knows the method of solving the two equations simultaneously. All of you know simultaneous equation solving.
Yes, ma'am.
So we are going to use that same technique over here. So what we are going to do, see, I'm just showing you, you can multiply this by -2. Okay, if you multiply by -2, this side will become -2 into, and this important thing, this will become -4a e raised to 2x. Likewise, this will become 10b e raised to 5x. And now what I can do, after multiplying this, I can add it with this equation. This and this equation you will add. If you add this, then this term will get cancelled. Getting it or what?
Yes,
What?
ma'am. We will have 15b e to the power 5x.
Yeah, yes, 15 b e raised to 5x, and this side you will have this -2 dy by dx plus d2y by dx square, right?
Yes, ma'am.
Okay, and then once you simplify, you will get this term. That means you will get b e raised to 5x. Getting it or what? Likewise, are you following the train
Yes,
of
ma'am. Yes,
thought?
ma'am.
Yeah. So the same way, we can find out a e raised to 2x also. For that, what I will do? I will do a new manipulation, and that will be, now I want to get rid of this b term. So I will multiply this by -5. If I do like this, here I'll get -10a e raised to 2x. Here I'll get -25b e raised to 5x. And then I will add these two, and this will get cancelled out. Okay, then we will get this -6a e raised to 2x. And from all that, if we just simplify, we will get this value. A e raised to 2x is equal to so much. Are you getting it? You're
Yes,
following?
ma'am. Yes,
Yeah.
ma'am.
Then what you'll do, once you have got this b e raised to 5x and a e raised to 2x, you will substitute in the original equation. So this a and b, automatically it will disappear. And once you substitute over here and simplify, this is the required differential equation. Can you do this last part and just check whether you're getting this? You all just try,
Okay.
do it. Just do so much. That means take these values of a e raised to 2x, b e raised to 5x, substitute in this main equation, and tell me if you're getting this final value. Yeah, is it, are you getting it?
I'm getting 2y dash, that is 2 dy by dx.
You're not getting 7.
No, ma'am.
Okay, let's wait for others also. Yeah, anyone else? If you have been able to verify.
Ma'am, I think there's a mistake in equation 1.3, the value of b e to the power 5x.
Okay, what value you are getting?
Ma'am, it would be 1 by 3 dy by dx
Mm-hmm.
minus 2 by 3y. I think the bracket is in a wrong position. That would be before 1 by 3.
Acha, so that means this, okay, so you're saying it should be this way here. Okay, okay, I understood. That means it will be just not 2 by 9, it will be only 2 by 3, right?
Yes, ma'am. Yes, ma'am.
Okay, let others also do it. Just y'all check. There could be an error also over there.
Yes, ma'am, it is 1 by 3 dy by dx.
Okay, 1 by 3 dy by dx minus 2 by 3y, not 2 by 9. No, that part I want you to
Yes,
just
ma'am.
confirm. Hmm?
Yes, ma'am.
Okay,
I'm
fine.
also getting that.
Same thing. Okay. And what about a e raised to 2x? That part?
That's correct.
That is correct,
That
ma'am.
is correct. Okay. So in the final answer, then what will be the change?
Just a minute, ma'am.
Just
Verify.
I'm calculating.
Hmm.
Ma'am, the answer is correct. There's a mistake in that bracket one only. It would be 2 by 3y only. I got the answer.
Okay. So that bracket part is there, but the final answer is correct.
Yes, ma'am.
Okay. All right, fine. So this we will just take it off and we'll put it here. And this answer is correct, right? Okay, so that is not an issue then. Okay, very good. So how many of you were able to get that? Just put up your hand icon. Let me see. Are you okay? All right. And Ayush also. All right, fine. Okay, very good. Now what we'll do, we'll just see. So now this is not some assignment or anything and all. These are questions which I will share with you in the Moodle itself. Okay, but right now I would very much like it that you should answer these questions. See, find out order and degree of the differential equations. Can you tell me one by one? First one,
Ma'am, degree 2 order 1.
degree 2. Just give me a minute. Yeah. Yes, order.
Order 1, degree 2.
Uh-huh. No.
Order 2, degree 1.
Yes, ma'am. Order 2, degree 1.
Highest order derivative. So d2i by dx square. So order is 2. And what is its power? 1. So degree is 1. Okay, second one. Second. Now you will have to use quotient rule, differentiate, and then find this, right?
Yes, ma'am.
Yeah, so it will take some time. So this one, this is easy. Just you have to remove the square root sign. So can you tell the order and degree?
Order is
Very
1,
easy.
degree is
Degree is, just tell properly. Now you will have to
Four.
square both the
Four.
sides.
4. Degree
Degree
is
will be
4.
4. Yes, degree is 4. All right, next one.
I think
Next. Now you'll have to remove the integral sign and all, isn't it? So you'll have to differentiate and everything.
product
Order is 3.
Order will be
And
3
degree is 1.
and degree will be
Degree
1.
is 1. Degree
That's
is 1.
right. Yes. Order is 3
degree is 1.
and degree will be equal to 1. Yes, this is correct. Okay, so students, so today's class, whatever we have done, have you followed it?
Yes, ma'am.
Yes or no? Okay.
Yes.
So we have seen the basic definitions. And then after that, we have seen order and degree of the differential equation. And we have also seen formation of the differential equation, right?
Yes, ma'am.
So now here are some problems where you have to find the differential equation from the following equations. Now all this material, whatever I am content I am taking here in the class, that I am going to share it on the Moodle. Okay. Usually what I do within a day or two after finishing with all the divisions, then I put it in the Moodle or sometimes before that also. Got it? So this will be my method. Idea is clear to everybody?
Ma'am, we
Excuse me,
are
ma'am.
not going to share the video, ma'am.
Video? This is not a video, no? Which video?
He was asking for the recorded sessions of this live class.
Actually, I am not recording the sessions, but the recorded sessions of the live class, now the college is recording. So the college has got the videos. We don't have.
Yes, ma'am Sachin Beware sir shares videos.
Yeah, I don't know how he does that, but the college has got the recorded videos. So you can contact the college then and ask them if they can share.
Yes,
Got it out? Because they are recording, no? The college is recording.
Yes,
This
ma'am.
recording which you are seeing is not from my side. It is from the institute side. Okay. So if you are interested in the recorded sessions, then you will have to contact the college authorities. Okay. Got it out?
Yes.
Yes, ma'am.
Content I will share, and class you have to attend properly, isn't it?
Yes, ma'am.
Yeah. So whether it is online, offline, see if the classes go offline, then you have to sit there in the class, isn't it? Yes or no?
Yes, ma'am.
You are agreeing, no?
Yes, ma'am.
So there you have to be actually present in the classroom. So here also what you do, you be present actually in the classroom. Okay. Got it or what? All the students?
Yes. Yes.
Okay, fine.
Excuse me,
Now,
ma'am.
CR, yeah.
Can we get the answers to these assignment questions?
First you solve. You can get the answers, but first I want from your side the solutions. Okay. Got
Yes,
it?
ma'am. Just to verify the final answer. is
After
correct.
you give me the answer, then I will be sharing with you for verification. Understanding?
Yes, ma'am. Yes.
Usually, I like to ensure that the students are doing all the things. Okay. Division 1, Ayush. I
Yes,
think
ma'am. No
today
one is
what
absent from
no
division.
one is absent because I
Yes,
can
ma'am.
see full strength. Division 6, I think so. You also, everybody is
Yes,
present.
ma'am.
Hmm?
Everyone is present.
Everyone is present. Acha, now one important instruction. This division 1, let me just
Yes,
stop
ma'am.
the share and bring up the timetable. Just 1 minute. I will just ref for the timetable. Division 1, tomorrow also you have Nilima madam's class, no?
Yes, ma'am.
Yes, ma'am.
Tomorrow is Friday. You are having her class at 4 o'clock, right? Division 1?
Yes, ma'am. Yes,
I
ma'am.
can see in the timetable. So tomorrow, once again, you join the class with the Zoom credentials of Division 6. I will put this on the group as well, but just you note it now itself.
Okay, ma'am.
So I don't think any other faculty has offered to take that class, right? Am I right in my understanding?
Yes, ma'am.
Yes.
Yes, ma'am.
So Ayush, you just note this, that tomorrow at 1600 hours, you have to join the class, but with the Zoom credentials of Division 6.
Yes, ma'am.
Is it clear to all of you?
Yes, ma'am.
Got
Yes,
it? Got. And I will put this information on the group as well, right?
Okay.
Okay, students. So do you have anything more to say to me? Anything else? Otherwise, we can then wind up this session. Yes, Nilesh. Nilesh, you have put up the hand icon. Do you wish to say something?
No, ma'am. No, I have done before, ma'am.
Acha, you had already. Okay. Okay, no issue. So anyone wishes to ask me anything, any doubts, any questions, or shall we then wind up this session? Yeah. Okay. So nothing. Okay. So we will wind up. Okay, students. So have a nice day. Okay. Thank you very much.